Welcome back, ladies and gentlemen. In this video, our goal is to discuss the two theorems regarding tangents of a circle. We're going to now give the tangent line some characteristics. First and foremost, we're going to talk about the tangent line to a circle theorem. This is what allows us to understand that the radius and the tangent line are always going to be perpendicular. Can you think of maybe why or how this is going to end up being beneficial to us? Well, if you remember the previous chapter that we just went through was all about right triangles, we're going to be actually able to utilize some of this information here and connect it with what we talked about with our right triangles and making some use of Pythagorean theorem and maybe at some point in time even SOHCAHTOA. The other idea that we're going to talk about is the external tangent theorem, all right, or external tangent congruence theorem. What we say is that a tangent, right, that is exterior, that we have in this external side of the circle, if tangent RS and tangent TS both meet at the same external point, which naturally they do at S, the only way this works is if RS and ST are congruent to one another. That's super, super important to understand. The only way that this works is if RS and ST are congruent to each other. So let's take a look at an example of how this comes into play. It says, is ST tangent to circle P? So it's just asking you, can you confirm? Remember, we can't assume, we want to confirm. So the question is what is going to confirm that ST is a tangent? Well, remember what we just talked about. We said that the only way that a line will be tangent to a circle is if it is perpendicular to its radius. And so if that's the case, we can utilize our radius and tangent perpendicular characteristic and kind of associate that with the Pythagorean theorem. Because if I can prove that this is a right triangle and angle T does in fact form a right angle, that's going to prove that ST is actually tangent to circle P. And so let's test it. We get 37 squared plus 12 squared. Oh, I'm sorry, I'm going the reverse order here. I should not say plus yet. Let's erase that. 37 squared equals 12 squared plus 35 squared, because remember, we want to compare, does this actually equal one another? If it doesn't, it is not going to work out. 37 squared is 1369. 12 squared is 144. And 144 plus 35 squared does in fact give us 1369. So yes, that is enough to prove that ST is tangent to circle P. What about another example we can utilize the idea of the radius and the tangent being perpendicular to one another? We're going to use this concept to prove or to find the value of the radius. In the diagram, point B is a point of tangency. This tells me that AB is tangent to circle C. So I can utilize this concept to find the value of R. I know that angle B is a right angle, therefore triangle ABC is a right triangle. So let's go ahead and use our Pythagorean theorem, and it's going to look a little ugly, but that's okay, we're going to get through it. So we have that 80 squared plus R squared is going to equal 50 plus R quantity squared. The entire hypotenuse is 50 plus R. Be careful, it's not just 50. So then we have 80 squared, which is 6,400, plus R squared equals, and now we have a binomial that we are squaring. So we're going to square both the outside terms. So we have 2,500. We're going to take the two terms, multiply them together, and double them. So we get plus 100R plus R squared. So when we have an r squared on both the left and the right hand side that are positive, this is great because you can subtract and cancel them out. And then so ultimately we want to get r by itself. So 6,400 minus 2,500 is 3,900. And then we want to go ahead and divide by 100, which identifies to us that the value of the radius is actually 39 feet. Okay? So there are two examples as to how we can utilize our radius and our tangent being perpendicular. Let's try one with a common external point. All right, so it says that RS and RT are both tangent. And so since they share this point R, we can confirm that RS and RT are congruent to one another. So our life really isn't too bad, and we can set these two guys equal to each other to solve for the value of x. And so 3x equals 24, and x ends up equaling a value of 8. And since these two guys are congruent, we can set them equal to each other, and that is enough information to prove that we have a value of 8 for x.